When I asked what we wanted to cover today, these were the three things that really I was asked to do. It was an alternate viewpoint. So we're coming from the energy side, not the transportation side. Something that's a little bit thought-provoking and also optimistic, so upbeat. So I figured, actually, as I was listening to some of the presentations, I'd start with some of the highlights. If we keep our CO2 emissions to 4 years, we have a 66% chance of meeting 1.5 degrees C. If it's 15 years, then it's 33%. It's 70 years to restore the ozone layer. Taxes drive behavior. Because EVs can't be taxed the same way, they're going to find new ways to tax us. Energy supply down, or energy supply CO2 is down by 50% in the last 20 years. High five, WWF, thank you. Transport's now above 30%. Oh dear. Critical materials, we haven't got a great way of recycling those, extracting them, but we might have a new way of using hydrogen, which we'll get onto in a minute. There's a whole new circular economy that might come around from this. There might be there's recycling opportunities and benefits from that. And the CO2 graphs are all fake news, to coin a certain US president's favorite phrase. Oh, and there's the soft squishy bit in the middle of the car that makes all these decisions so we can't control it. Is that optimistic enough for everybody? Are we all feeling good? Brilliant. So I don't want to dwell on some of the, I mean, some of those are very relevant and they're very important, but I think what the important thing here is there's a whole range of opportunities that we can actually leverage from this. As I said, I'm from the energy systems catapult. I'm not in the transport world. We touch against transport, and we do cross over at points. But there's a wider infrastructure here that's at play. So we've got the supply, which we've already touched on with one of the questions earlier. There's the infrastructure, which gets the energy actually into people's homes, people's cars, and where it needs to be. There's industrial energy usage, and also industrial energy wastage. There's buildings, and then there's transport. So there's a whole big pattern here, and there's multiple ways that energy gets from one to the other and is transferred around. When we look at it at the energy systems catapult, we look at multi-vector, so we look across oil, gas, electric, hydrogen, solar, whatever you can think of, and we bring all of these into one place, and then we start to understand how can we optimize usage of those fuels across the board. And it's not that simple. There's all sorts of trade-offs that you need to be able to consider. And the one that I've realized that's not in this slide is what about government? What happens when they put in levies and they put in taxes and subsidies? How does that change the pattern of what you're looking at? The next thing that we look at as well is when we look at transport as a vector, transport's a very important piece. And you've got all of these different methods of transport. And I put really the ones in there that have got an engine and don't use pedal power. But planes, trains, the little diagram of the Tesla truck there, the cars, they're all very different in the way that people use them. So there's estimates at the moment that heavy vehicles could potentially hit 900,000 on the road by 2050 and 200 billion tons per kilometer of freight, or 200 billion ton kilometers, sorry, of freight. People using cars and personal travel is 10x what people use rail and 20x bus and coach. So again, going back to the previous conversation about how do we incentivize people to change their behavior, to take on some more of these mass transit options, how do we encourage that to help decarbonize and help reduce the energy demands on the system? When we talk about fuel types, obviously oil is still there. It's not going away anytime soon. We can talk about it all we like, but it's still here. It's the incumbent, and everybody's comfortable with it. We've also got biofuels. They can help, but we need to start thinking about those now to be able to get the long-term gains out of the back of it. And also, where do we produce them? Where do you grow it? Or how do you generate it? Electric. I had the question, how do we get the supply there? Now, as far as generation, There's all sorts of generation out in the UK and around the world, but then you've got to distribute it through the wires, through the networks, and how do you make sure you don't overload those networks? And there's some very clever technologies that can do that, and then there's opportunities off the back of that. And then there's hydrogen. We've already mentioned it a couple of times, but supply chain, how do you generate it? How do you actually then get it into different distribution points and used around the country and around the world? We're looking at a couple of projects that are looking at low usage areas, but also have high access to renewables. What if we take that excess energy generation and drive it into hydrogen supply? What does that do in that local area and also the national area? There's some interesting implications there. And then finally, I wanted to spend some time on infrastructure and interaction. There's a whole range of different ways that people interact. I think we've heard mobility as a service. At the Energy Catapult, we're looking at heat as a service, so for domestic supply, how instead of paying for kilowatt hours, do you pay for your home to be a certain temperature? Do you pay to be able to go a certain distance? And then products are becoming more of a service type environment. So now that I've hit mobility as a service, I wanted to run through, I've got distributed ledger, Internet of Things, big data, agile framework, human-centric, smart, disruptive, scalable, and connected autonomous vehicles. And I hope somebody has got buzzword bingo from that. However, all of those things will help us develop. They will help us to grow. They will help us to realize those opportunities. How they actually do it is going to be in a wide range of different ways. And it's all about being able to cross vectors, cross the energy supplies, cross the energy usage, and cross the loads, so that we balance out our demand, drive towards decarbonization targets, but we also realize value out of the chain as well. So how do we take that? And part of that is going to be by being able to share some of the data that's used. So I jumped on just before I came on, and about half an hour ago, our energy generation was 53% gas turbines, nearly 10% coal, 18% nuclear, 6.5% wind, nearly 4% was coming from France, and 5% was biomass. So I've already got a view, fairly live, fairly active, of what our energy generation is actually at this current time. How can I use that? How can I take that and start to generate something that's delivering clean energy into vehicles, into hydrogen generation, into biofuels? How do I work with that? I've got data. I have it, and I can use it. So the more that we can share data and the more that we can operate as a system of systems type environment, and if anybody had failed to get bingo, that's probably your last one, that's going to be key moving forward. And that's what we're looking at the Catapult. And we also look at that with our sort of brothers and sisters at the Transport Catapult, Future Cities Catapult, and others, as to how we merge these things together and how do we work across vectors and across supply chains. I think the last thing I wanted to point out, and I think we touched on it on the regulation side of it, is the technology is moving so fast. Infrastructure and legislation and regulation it's lagging behind it. There's a lot more that we can do today than we could when these rules and regulations were formed. How do we adjust? How do we adapt? And how do we move on to make sure that we can actually leverage everything that we're doing? I don't know that I can't give you an answer today. I'm not sure I could give you an answer tomorrow or even next year. But it's something that we have to take into account. If we don't, then we'll just be held back by our own rules. And in that case, nobody wins. I think just to wrap, and I think I'm not sure I'm getting the hook off the stage just yet, this multi-vector piece, I think it's very important. We've got a lot of variety around us as far as technologies and as far as propulsion systems, automotive, aerospace, and planes, and boats and everything else. How do we make that work? How do we pull it together? How do we share our data across these platforms? If we focus on fuel alone, we're limited. If we break down the silos, there's a lot of value to be realized in this. I think that's one of the reasons why the catapults have been put into place, is to help people work through these issues and work through these challenges. And I'm happy to talk to any of you about it as far as the energy system side, and I'm here until probably they kick me out. So thank you.
Thank you.